Alexa, what is Git?
A gate or gateway is a point of entry to a space which is enclosed by walls. Gates may prevent or control the entry or exit of individuals.
Alexa, what is Git?
Git is a distributed version control system for tracking changes in source code during software development. It is designed for coordinating work among programmers, but it can be used to track changes in any set of files.
Alexa? Thank you.
You bet.
If you work with files, you probably need some kind of tool to manage versions of the files, create backups regularly, and sometimes collaborate with others. Exactly, that's why version control systems were created, and Git is the most popular version control system nowadays. Although Git is mostly used by developers while writing code, it works fine with any types of files. Even if you are a designer, a writer, a lecturer but work with files and probably need a tool to manage versions of the files and sometimes collaborate with others, Git might be the right tool for you. Hello guys, what's up? The Codeholic is here and welcome to my channel. On this channel I do coding tutorials and challenges, so if you are new to my channel, consider subscribing. I have created a couple of slides trying to illustrate the most essential parts of the Git, and I will try to go through these slides as quickly as possible so that we can immediately jump into the editor, install Git and see everything in action. Here is official explanation of version control system from Git's website. Version control is a system that records changes to a file or set of files over time so that you can recall specific versions later. Git has two main features: to manage versions and make co-working easier. When I say manage versions, I mean that at any point you can create a snapshot of your project folder, and Git also saves the author who made that snapshot and the date and time when the snapshot was made, and later you can switch back to previous version at any time. When you have your own local project folder, you can push all your work to a remote server, which is sometimes called remote repository or remote Git server. The most popular remote Git server is GitHub, but there are other also really popular ones such as GitLab or Bitbucket. You push your work to remote server and then someone is able to pull your work from that remote repository, make his own changes and push back. We will see a better example of this in next slides. Okay, that sounds cool, but how can I start managing versions of my project? First, we need to install Git, which we'll do in a couple of minutes. Git comes with command line and GUI. In this crash course, I'm going to fully focus on command line. Then we need to initialize Git project or Git repository by running command git init. After this, we can already start add files in the project, and when we call git add, Git is already tracking to that files and basically understands every change which is made in this file. Then you can make, of course, changes to these files, and then finally you take a snapshot. You make a commit of your current project state. After this, you can add new files again and call commit, or you can modify the files. There are basically no direct flow. You can add files, modify and then commit, or you can add files and directly commit, or you can modify already existing files and then commit. Every file which is in the folder of Git project has 4 states. Untracked means that Git is not watching to that files yet and doesn't care what is changed there. Staged, which means that file is marked to be included in next commit. Unstaged means that file won't be included in the next commit, but Git is watching changes for that file. And the last one is committed. The snapshot of the file was made. And as I said, when the snapshot is made, it's almost impossible to lose the data of the file. Let's see an example. So I created a folder and I created index.html right there. Then I created Git repository by calling command git init. My file at this moment is untracked. Okay, this U indicates basically that it's untracked. Okay, then I start tracking of the file, and the file is added in the Git project. Then I modify the file and the file is modified, and then I move the file into staging area, which means that this file is added to the Git project and it will be included in the next commit. And then I commit the file and the Git folder is absolutely clean. Now let's make this a little bit complex, and I added one more file, which is app.js. This file is untracked at this moment. Git is not tracking to that file. I call git add, and the file will be included in the next commit message. Then I modify the file, and it is modified at the moment. And because it's not in staged area, it's unstaged area, it won't be included in the next commit. Then I call git add again, which changes the file state into staged, and then we commit and the file is included in the next commit. This approach basically gives us possibility to have a really rich commit history, so that we can switch back to the previous version at any time. So every Git commit has its own hash, a unique identifier of that commit. This is the short version of the hash right now, what you see, but we will see a longer versions of the hash whilst create our first Git project. Alright, let's see how Git works on remote. There are 3 users, Brad, Mary and John, and they want to work on the same project. So Brad started working on the project, create a couple of files, couple of commit messages, and then he needs to push that in order Mary and John to somehow take it from the remote repository. So first, Brad needs to sign up on one of the websites, GitHub or GitLab, to push his changes there. So after that, he pushes the changes, then Mary and John needs to clone the repository on local machine, and they will have the exact same files Brad has. Now Mary decided to add app CSS in the project, and she did so, and she needs to push the changes now in order that Brad and John to take the changes. Okay, so she pushes the changes on the remote repository, Brad pulls the changes, and now in local repository Brad also has app CSS, and John also pulls the changes and he also has app CSS. And that process basically is unfinished process until the project is in the development process. Okay, let's see one more slide and then we will install Git and make our hands dirty. Okay, Git branching, which is sometimes called Git's killer feature, is really important one to know when working with Git. Okay, branch is a lightweight movable pointer of one of the commit messages. On every commit you make, branch pointer moves forward automatically. By default, when you initialize a project, it creates a master branch. Okay, let's have a look. So let's imagine that we have several hundreds of commits on that master branch, and now we decided that we want to create 2 new features in the project, feature 1 and feature 2, and they must be developed on new branches. They probably can be developed by different developers also. So we create 2 branches, feature 1 and feature 2, and they are developed like independently. Couple of commits are made on both on the branches, and at this time even master branch can develop. A couple of commits can be made there, and we discovered that we have a bug on the master branch and we want to fix that bug. So we create a bug fix branch. At this moment, feature 1 is already ready enough to be merged on the master branch. So we merge it, and now feature 1 changes are on the master branch. Okay, bug fix develops. There have been made a couple of commits, and we need to merge these also to the master branch. So we do like this. Feature 2 is a little bit larger, so there are a couple of more commits made, and finally it is also merged to the master branch. And that process continues. Okay, so we make one direct commit on the master branch, then we created new branch feature 2, we developed it and merged it to the master branch, then new branch can be made, feature 4, new commit can be made on the master branch, new bug fix branch can be made on the master branch, and just like this. So this is like unfinished process until the project continues, and this is a small demonstration of Git branching. In a real world projects, you will have much more branches than I have demonstrated on the picture, but I think this makes sense. Okay, let's now install Git and make our hands dirty. So let's type download Git. Let's open the very first link and download Git for your operating system. Okay, once it's downloaded, let's install it. The installation is basically really simple. We just need to follow the instructions. At one point, I only change one value in the installation process. Okay, so next, this one, check out as is commit Unix style line endings. This is what I generally do. Then that's not like mandatory for you. Okay, once the install is done, let's launch the Git bash. And that's basically terminal, Git terminal, okay? That comes with the Git. If you just don't open it, you can always open from the start menu. Just type there bash, Git bash, and hit the enter, and it will be opened. Now let's open VS Code and create project there. Okay, so here I have opened empty folder called Git Crash Course, and let's create a couple of files right here. I'm going to create index.html first, generate some boilerplate code, and I'm going to now commit and push this. Okay, so for this I need to go to the same folder using my Git bash where the project is. Okay, so right click, reveal in file explorer. Okay, that's my Git Crash Course folder. Right click right here and open Git bash. Now I'm going to run git init, which initializes empty Git repository. And then I'm going to introduce now a couple of Git commands. Git status, for example, which gives you always the current state of the repository. And now we see that we have untracked files and there is index.html. Okay, in order to commit this, we need to first call git add. Okay, git add index.html, and this file will move into staging area. It's also now tracked. Git status, and we see right here changes to be committed. New file index.html. Okay, let's modify this index.html actually. So let's add right here hello Git. Okay, let's save this, open the Git bash. Actually, I'm going to close the second one. And let's type now Git status again. So now here is different output. Changes to be committed, index.html, but changes not staged for commit. We once called git add on index.html and it will be committed, but actually the changes what we made won't be committed because the changes is not in the staged area yet. Okay, so for this we need to call git add index.html once again and then call commit, or we can directly commit and include the change. Okay, so for this I'm going to do git add index.html and commit this for now, but I'm going to show you the second approach also. Git commit, and here we have a couple of options. If we directly call git commit, we need to specify, first of all, that's absolutely necessary. First of all, we need to specify the name and email of the author, of me. Okay, so we're going to run git config -- global user email, and you need to write your own email right here. And we need to config now name. User name is my name, and you need to write obviously your name. Okay, now I can already call git commit, and now this opens the default editor, which is Vim on Windows. Okay, so here we can write the commit message, what should be committed. Okay, so we need to first type I on your keyboard to move into the insert mode, and then we can give it a comment like initial commit, and let's create one empty line right here, then escape and colon W and Q. W means write, Q means quit from that Vim editor. Okay, so let's hit enter, and now commit was made. Git status gives us nothing to commit, working tree clean. There are no files right now in the unstaged or in the staged area. Let's run git log now, and which will give us the commit history. And this is our commit history. The author is me, the date is now, this is the commit message, and this is the commit hash, the unique identifier of the hash. So this is the really long hash. Make sure that it won't repeat, but actually the first couple of characters, like I don't know how much, 8 probably, the first 8 characters are sometimes also used to identify the commit message. Okay, let's move forward and let's create one more file in the project, app.css. This is a new file. Let's save this and let's now type git status. Git status. Okay, this is app.css. Actually, to follow the same example as we had on the slides, let me rename and call this into app.js. Okay, we have app.js. And the git status will give us that we have untracked files app.js. Now I need to run git add and dot. This dot basically means that take every file which is not tracked yet and move into staging area. You need to be very careful when running this git add dot. It adds all the files into staging area, and sometimes we don't want all the files to be added in the staging area. So my advice is always type git status. Whenever you run some command, type git status. Like for example, git log, you see the current git status. Before you make actually a commit, type git status. Okay, this gives the whole picture. If before you run git add, make git status. And now we know that we have only one file, git app.js, to be moved into staging area, and that's exactly what we want. Okay, so I'm going to run git add dot. I could write also app.js, but I prefer to write git add dot, and that means that the file git status now status, and the file is moved into the staging area, and it will be included in the next commit. Okay, let's do something similar. Let's write console log hello git from JavaScript. Okay, now let's see status, git status, and it tells something similar what we had for index.html. Now we need to, I'm going to include now that app.js without calling add. Okay, git commit -a, and that -a basically means that include unstaged changes in the commit. Okay, git commit -a, hit the enter, that opens the exact same vim where we first type I, and then we add commit message, add app.js, and escape, colon, right and Q, W and Q, hit the enter, and the commit was made. Git log gives us now 2 commits, and each of them has its own unique identifier hash. Now type git status, and the status is absolutely clean. We don't have anything. Now let's include that app.js into index.html. Script source is app.js. Save this, and now let's type git status. Okay, so we have one unstaged changes. I need to run either git add now for index.html or git commit -a to include that change also in the next commit. Remember that for new files, git commit -a doesn't basically do anything. -a only includes the files which are tracked by Git but not moved into staging area yet. Index.html is definitely tracked by Git. So for here, I need to run git commit -a. And now I'm going to introduce one new parameter, -m. This -m basically means that don't open that standalone Vim editor. Instead, I'm going to provide my commit message right here. Git commit -a-m include app.js into index.html. That's my commit message. Hit enter, and the commit was made. Git log now gives me 3 commits. This one, and this one. It's really cool. Now we have already created the project, and I want that project to be shared to someone else. If I type git status right now, I don't have anything to commit, anything to include into the staging area and so on. Now we need to register on the GitHub, create repository, remote repository there, and push our changes to GitHub. Okay, let's go to the GitHub, github.com. If you are not registered on GitHub, you can just follow the instructions, register, confirm your email, and that's it. So I'm going to log in with my credentials right now. Okay, and I'm going to create a new repository. Right here, plus new repository. And I'm going to call it Git Crash Course. Okay, the description is kind of optional. Actually, I do already have Git Crash Course, so I'm not going to actually create this, but you need to name a repository. You need to give the repository name, which is unique for your account. And then you need to create the repository. Okay, actually I'm going to go to my profile, go to repositories, and right here I have somewhere probably Git Crash Course, right here. Okay, this is the old one, but it's empty repository. So whenever you create repository, it will be empty and you will see result like this. Now here we also have kind of instructions what we need to do. Okay, actually my my local Git project is already set up, so I need to follow this instruction. Okay, so I'm going to copy this line and explain it right now. This basically tells that I'm going to add new remote, a remote add. I'm going to add new remote, and I'm going to give origin as a name to that remote, and this will be the remote link. Okay, so this basically is a Git URL, SSH URL. Every Git endpoint, every Git repository has two types of URLs, SSH URL and HTTPS. So HTTPS URL, when you use HTTPS URL, every time you push or pull, you need to pass authentication with username, your GitHub username and password. Okay, so for SSH, it's more advanced. You need to generate public and private keys and like put your public key right here on your GitHub account, which I'm not gonna do. I'm probably, if you are familiar with like HTTPS, probably you can get familiar with SSL. So for this, I'm gonna do with HTTPS because it's simply easier. Okay, I'm gonna copy the HTTPS URL right here, git remote add the remote name origin, which is kind of common name for remote, and I'm gonna put here right here this URL, HTTPS URL. Okay, paste, hit the enter, and we added remote repository. I can check this, git remote -v, and that tells me that I have added the origin remote, and this is the endpoint for fetching and for pushing. Fetch means to take from the remote. Now I need to push my changes. Git remote, git push origin master. Okay, and that will push all my local changes to that origin, to that remote on the master branch. Locally, I'm working on the master branch. Okay, hit the enter. It now asks me to enter my GitHub username and password. So I'm gonna provide them, the Codeholic. Okay, hit the login. Now it started pushing, and once it's done, I can reload on my GitHub page, and I see my changes right here, index.html and app.js. Now we need a second user who will clone this and just experiment on his own account. So for this, I'm going to use my virtual machine, my Linux virtual machine, and I'm going to clone it on Linux. Okay, here is my Linux virtual machine, Ubuntu 19, and now we need to clone the repository right here locally and experiment and make some changes. But first, we need to make sure that we have installed Git right here. So I'm going to open terminal and type there Git. That doesn't give me any output, command Git not found, so we need to install sudo apt install git. We need to provide our root password and hit yes. Okay, Git is already installed, type Git, and it gives me that output. Now I need to clone the repository. So for this, I'm going to open now my GitHub. Go to repositories, Git crash course, and I'm going to take that HTTPS URL right here. This repository is public. So I made it public when I created. If you make it private, then you need to be authenticated to clone this. But right now I can clone it without username and password. Okay, so I'm going to go to the documents folder, and right here I'm going to clone Git. I'm going to call Git clone and Git crash course. That's the endpoint, and optionally I can specify here local folder name where I want it to be cloned, like a Git course, for example. But I like the name Git crash course, so hit the enter, and it's now cloned in the folder. Let's open that documents, and here I have Git crash course, and here I have app.js and index.html. Let's navigate to that folder, Git crash course, and type git status. Okay, and I see nothing to commit, working tree clean. Now let's add one more file, app.css, for example. Okay, so I'm gonna open this. Actually, do I have VS Code installed right here? Oops. No, I don't have VS Code installed right here. So I'm going to simply create one file, app.css. Okay, that file was created right here. And now let's type git status. And here I see untracked files, app.css. Again, I need to call add app.css or dot to start tracking that particular file, and git status, and it's in the staged area, git commit -m add app.css. And here again I need to configure my environment, so I'm going to quickly do this. Okay, I configured it, and let's run now git commit. Let me actually hit the upper arrow, git commit -m add app.css, and the commit was made. Git log shows me all the commits made in this repository: initial, adding app.js, and finally add app.css. And now I need to push my changes back into GitHub remote repository. Git push origin master. Let's push everything on master branch of the origin. And now it asks me the username and password, so I'm going to provide it. And it was successfully pushed. Now if I reload in the browser, I see app.css right here. Let's now open our Windows terminal. Okay, so I need to now pull the changes made in the Linux machine by another user. Okay, so git pull. I want to pull from origin remote master branch. Okay, and here it is. App.css was added, and now locally I see that app.css. Okay, now I'm going to demonstrate Git's killer feature, branching. So we need to create a new branch. Git checkout -b, which means that create new branch and go to that branch immediately. Git checkout -b, and I'm going to give the branch name. Okay, for example, add header. That's the branch name. So we switched to new branch. Now if we type git status, I see right here on branch add header. Now I'm going to add header component in the HTML, just like this, and I'm going to commit this. Git status before commit, git commit -a -m add header, git push origin master. My bad. So we are on add header. So we need to push that new branch. Git push origin add header. So I'm gonna push that add header branch on remote origin. And Windows basically saves your username and password once you enter it, and you don't have to enter it second time. So that's actually pushed. Now let's open and let's reload. And here in the branches, we have now two branches, master and add header. So now we can make some changes inside that. We actually made some changes on that add header branch, okay? We actually added the header. Now let's move on the Linux machine and fetch that branch and make one more branch and then finally merge them together into the master, okay? So first let's go to the Linux machine. So here I need to run git fetch origin, which means that I want to fetch everything what is new on the origin, and I hit the enter, and that now fetches locally add header branch. Okay, so let me open right now index.html using one of the editors, or let's immediately open it in the browser. Okay, so here is hello git. Now let's switch to that add header branch. Okay, git checkout add header. Okay, checkout -b creates new branch and moves that branch. Git checkout just switches to already existing branch. Okay, I switched to the add header branch, and if I reload the browser right now, I see header here. So now I can see the header. But I want to create something new. I don't want just to make some changes on that header, okay? Let's imagine that the add header is done by the Windows developer, and this is done by the Linux developer or something else. So let's check out to master branch again and create new branch, git checkout -b, and let's call it add sidebar. Okay, so I created new branch, add sidebar, and now let's edit that index.html file with some editor. Actually, I'm gonna open using Vim index.html. I don't have Vim, so let's use Nano. You can open this with any editor you prefer, just I want to edit this, okay? So here is my index.html, and I want to add sidebar, okay? I don't see header right here because I am on master branch. Header was added into add header branch. So I'm gonna create right here one div, okay? I'll give it a class of sidebar, and let's close that div. And right there, I'm gonna just write for now sidebar. Okay, so I created sidebar. Someone else created header. So these are two different features. Now let me comment this. Control O, enter, Control X. Okay, not comment, but I just saved the file. Git status, and I see that index.html was modified. I haven't mentioned, but you can type git diff to see what is actually modified, okay? So when I type git diff, it tells me that this plus the green text was added, okay? And that's basically it. So this is the identical changes, okay? So now I can call git add dot for that index.html, git status makes it green, git commit -a, not -a, we don't want -a anymore because we just called git add, -m, add sidebar, okay, hit the enter, git push, origin, add sidebar branch. I want to push this on add sidebar branch. I'm going to provide again my username and password. Windows saves this information, Linux doesn't save this. Okay, I pushed that, and if I go to the browser right now, I see now 3 branches, add header and add sidebar. Okay, now let's merge these things into master. Okay, so let's do this right here. So now my Windows user can fetch origin and he can see that sidebar branch. But let's merge all these things into master. Okay, let's first merge header into master. So git checkout to master branch, and I'm gonna call git merge add header. Okay, so I want to take this add header changes and put it in the current branch. Okay, and right now I'm in the master branch. I hit the enter, and here it is. So index.html was changed, and if I type right now git log in the master branch, first of all we have too many logs right now. And here I see the latest change is actually, where is it? Let me type this again. Git log. and here it is, add header, which was made on a add header branch, but now it is also in the master branch. Okay, now let's merge this add sidebar also. Git merge add sidebar. Okay, hit the enter, and here was made like a conflict. Okay, so the merge was made, but the thing is that we took the same master version, the Windows user and the Linux user took the same master version, created separately two different things, and now this needs to be merged into the same branch. So that causes a new commit. It's not conflict actually, but this causes new commit, and this commit is merge commit. Okay, so I just call it whatever it is, like merge branch add sidebar. This is the commit message. So I save this, and now commit was made. And if I now type git log, I see right here add header in the master branch, add sidebar, and I also see that merge branch add sidebar. Okay, so that's basically the whole process, how it goes. Sometimes when you make changes, the Windows user and Linux user, if they make changes on the exact same line, that would cause conflict, and we need to fix that conflicts manually. But that's just beyond the scope of this crash course, so I'm gonna pause right here. I hope this is clear. If not, just let me know in the comment section. And if you find this video useful, hit the like and subscribe buttons and share this on your social media or to your friends. We have these changes on master branch now, and we need to push this so that Windows user can take all the changes, all the mergings of header and sidebar into master branch. Okay, so we need to run git push. Actually, before I run the push, if I go to the master branch, I see right here on the master branch only 4 commits. Come on. Okay, so here I see only 4 commits. The latest commit is add up CSS. But right here, if I type git log, this is the add up CSS, and the commit messages, we can compare the commit messages. Okay, 385. This is the commit message, the latest commit message on GitHub. But these 3 commits which have been made on master branch is not yet pushed. So we need to run git push origin master. Okay, and this asks me username and password again. And as I said, we are using HTTPS URL of the repository, and that's why it asks username and password every time. If we use SSH type URL, we won't have to provide that username and password anymore. Okay, let's do this. Let's go to the first we need to log in. Okay, and then we need to add SSH public key right here. Let's go to the profile. Let's go to the settings, SSH and GPG keys. Okay, let's click that one, and we need to generate that new key. Okay, new SSH key, and we need to put that SSH key right here. Okay, the generation instruction will be written right here. Check out our guide to generating SSH keys. Generating new SSH key and adding to the SSH again. So we need to run the following command. Okay, so I'm gonna copy this and run on my Linux machine. Okay, so I want to generate key, and this is my email, and it asks me the path where I want to save the key. I'm gonna go with the default one, hit the enter. The passphrase, that's basically additional security, and I'm going to leave it empty because otherwise it will still ask me to provide my passphrase. So the key was actually generated. Now I need to take that key, go to my home directory into SSH folder, and I want to take id_rsa.pub. Okay, that's my public key. There is also private key in this folder, SSH folder, just this is only for me. The public key is for everyone else. So I'm gonna take this public key and put it right here, and I'm gonna give it a name, Ubuntu 19, click add SSH key, and this public key was added. Now I need to change my remote URL from HTTPS into SSH. Okay, so previously I had this URL HTTPS. Now I need to use SSH. I'm going to copy this and I'm going to change my remote URL. Okay, if I run git remote -v, this tells me that this is my URL. Now I'm going to change this git remote set -URL for origin. I'm going to set this. Okay, now if I run git remote -v, it tells me new URL. Now I can call git push origin master, and as I said previously, I had only 4 comments right there, and when I run this, it only the first time it asks you this confirmation, and I'm gonna hit yes, and that's it. It won't ask you username and password anymore, and you can push and pull just like this. I reload, and here I see these 3 changes. Okay, let's do the same thing on Windows. Okay, so we need to go to the where do we need to go to the settings, go to SSH and here is my newly added Ubuntu 19 keys. So I'm gonna add now a new key, and actually let's generate this for Windows also. Generate SSH key, adding a new SSH key. Okay, let's generate this one first. I'm gonna copy this, open your Git Bash terminal and paste this right here, and let's generate for your email. Again, I'm gonna go with default location where it is saved. The passphrase, I'm gonna set it to empty, and that's it. It was generated. And I'm gonna cut this again. I'm gonna output this again from my home folder. Now that one basically will be saved in your home folder .ssh folder. Okay, so go to the home folder SSH, and I'm gonna take out that public, open that public, take out the value, and save this on my GitHub. Okay, go to the GitHub, add new SSH key, Windows, Git crash course. Okay, this is just the name. You can name whatever you want. Add new SSH key. Now let's open the Windows terminal, git remote -v. This is the HTTPS URL. I'm going to change this into SSH. So let's go to the repositories. Take that SSH URL, git remote set URL origin, this one, and git pull. Let's type git log first, and we only see header right here. Actually, we are on the header branch. Let's check out to master branch, type git log, and I see right here the last commit is add-up-css. So let's run git pull origin master, hit yes, and here it is. So we pulled all the changes. Now if I type git log, I see the changes which have been made from the Linux machine, the merging changes actually. Once I merged add header and add sidebar branches to master, now I can delete them. I don't need them anymore. So the 2 different features have been developed on 2 different branches, and it's merged to the master, and we don't want that anymore. So to check all the list of the branches, I'm going to type git branch. Okay, and this gives me that locally I have add header and just master. Okay, so I don't have add sidebar because that was added on Linux machine and I haven't fetched it locally. So I'm going to run git fetch origin. This will fetch the add sidebar locally, and now I can check out to that branch. Okay, git checkout not minus p, just add sidebar, hit the tab and it will also end, and here it is. Now I am on add sidebar branch. Okay, git branch, this now shows me all the 3 branches, add header, add sidebar, and master, and I can go to the master branch, git checkout master, and I can delete these branches. Git branch -d to delete it, add header. Okay, and the branch was deleted. And let's delete for the sidebar also, but that was deleted locally. Okay, it was not deleted on remote. If I type git branch, I see only branch, but on the remote still I have here 3 branches. Okay, I need to push the deleted branches to the remote. Okay, for this I need to run git push origin -- delete add header. Okay, I'm gonna hit enter. The authentication basically is passed through SSH key, public private SSH key, and the add header branch was deleted. Now let's run add sidebar to delete it. And here it is. Let's reload the browser of GitHub, and here we see only one branch. If you just want to create branch, just don't go to that branch, you can type git branch and the branch name, for example, new-branch. Okay, so this will create new branch, and we can type git branch, and here we see new branch, but we are still on master branch. Okay, I generally use git checkout -b because whenever I create branch, in most cases I just want to move that branch also. Alright, that's it guys, and I hope you enjoyed it. Let me know in the comment section if you liked the video, or if not, what you did not like. Thanks for watching, don't forget to hit the like and subscribe buttons, and see you in the next time.